In this video, we will show you how to compute inverse probabilities. That is, we calculate a range of values that correspond to a probability value. We will also be considering both continuous and discrete distributions in this video. From the probability simulation pane, select Probability, scroll down to Probability Calculator, and here you will see the options to choose between performing a continuous probability calculation or a discrete probability calculation. Let's first start by exploring the continuous distribution calculator. At the top of this dialog box, you will see two radio buttons. To calculate values from probabilities, we need to hit the Probability to Values radio button. To learn more about the Values to Probability radio button, please reference our video, Probability Calculator. Now by clicking on the Distribution dropdown, you'll be able to select the distribution of your choice. Once we select the distribution, text boxes for specifying the corresponding parameters will be displayed. The four types of calculations available are lower tail, upper tail, between tails, and outside tails. You can also perform multiple calculations at once by hitting the green plus button in the bottom left corner of the dialog box. Each calculation can be given its own unique name should you want to filter more easily between all calculations. Let's begin by clicking on Calculation 1 and keeping the default assumptions of a normal distribution with mean 0 and standard deviation of 1. And for this first calculation, I'm going to calculate the interval of the lower tail that corresponds to the probability of 0.97725. Now click on Calculation 2. For our second calculation, we will assume an F distribution with numerator degrees of freedom of 5, denominator degrees of freedom of 7, and a non-centrality parameter of 0. Let's find the value that would leave us with a lower tail probability of 0.5 and an upper tail probability of 0.05. You can see the visuals of these calculations by selecting the graph checkbox, which is next to the calculation name, or on the bottom lower section. Now let's hit the preview icon. In this report layout, you will see the statement indicating the distribution of our random variable, the expected value and the variance, and the value statements in both plain English and mathematical notation, along with the distribution plot. By scrolling down to the Calculation 2 output, you will see the same output structure as Calculation 1, but with the F distribution. I'm going to click back on the Basics button to look at other features available within the probability calculator. If we uncheck the graph feature, the access limit and the tolerance options are no longer interactive. The access limit boxes let you enter the left and right access limits on your graph in case you want to zoom in or zoom out of your plot. When no access limit is specified, the tolerance boxes can be set to determine how far the x-axis should be stretched on the right and the left. For example, if we set the right value to be 0.0003, then the right tail of the distribution will be extended to the point where a probability of 0.003 remains in the right tail. It's also important to note that the x limits will overwrite the tolerance should you enter values in both. Let's hit the green plus button and create a new distribution calculation so that I can show you how the x limits and the tolerance features work. Calculation 3 will be a duplication of the distribution parameters from Calculation 2. The only thing I'm going to change is that the x limits are going to go from 0 to 5, giving us an alternative way to visualize this calculation. Let's hit the preview icon to see our results. As you can see, Calculation 2 shows our plot with the default tolerance values in Rguroo. However, Calculation 3 shows the same plot, but with an emphasis on the access limits that we set from 0 to 5. I want to show you one more example but this time using a discrete distribution. Scroll back over to the Probability Simulation toolbox, select Probability, scroll down to Probability Calculator, and then click on Discrete. After hitting the Probabilities to Values radio button, you'll notice the Discrete Distribution Calculator looks pretty much identical to the Continuous Distribution Calculator. In this example, suppose we have a binomial distribution with 20 trials and the probability of success being 25%. Let's calculate the value for which the lower tail probability is 0.8. Click the Graph checkbox, and we are now ready to hit the preview icon to see the results. Here we see that the smallest value that our random variable can take with a lower density tail of 0.8 is 7. To learn more about various distribution parameters, please refer to the appendix titled Probability Distributions from our user guidebook. And if you would like further details and examples of how to use continuous and discrete probability calculators, we encourage you to also reference the chapter Probability Calculator.